Hello everyone. In this video, we are going to talk about the concepts of functions from the chapter 2 Relations and Functions, class 11 Max. See, we have already discussed about the Cartesian products of sets, relations, range, domain, codomain, image, etc. in our previous videos. I will provide the link in the description box. If you want, you can watch that. Anyway, you see, we will be discussing about the two examples, example 10 and 11 in our next videos. Please refer that also because those two numerical questions are actually related with the concepts which we are going to discuss now. Okay, so you see, functions, it is one of the important concepts in mathematics. It is a special type of relation. Function is a special type of relation. See, there are many terms such as map, mapping used to denote a function. See, we will be discussing this definition number 5 and 6 also in this video. So, let us see the definition 5, which is a relation f from set A to set B is said to be a function if every element of set A has one and only one image in set B. That is important. Every element of set A has one and only one image in set B, then we can consider that relation as a function. For example, consider a relationship between two sets, set A and set B. See, this is set A and this one is set B. This is an arrow diagram representation. See, second element in the relation, that is actually called as image. Okay, so 8, 16 and 24, they are the images of these elements in the first set. So here you see, every element of set A has only one image in set B. 2 has only one image 8, 4 has only one image 16, 6 has only one image 24. So this relation is a function. Okay, because here every element of set A has an image and every element of set A has only one image in set B. So we can consider this relation from set A to set B as a function. You see, the function f from A to B, that is actually denoted like this. F is a function from A to B. Now, let us consider another relation which was actually discussed in example 7 in our previous video. So here we have two sets, one is set A, another one is set B. These are the elements in set A, these are the elements in set B. And you see, is this relation a function? No. This relation which is from A to B, it is not a function. Here, this is not a function. Why? Because for a relation to be a function, every element of set A should have an image. Okay, so here the element 6 has no image in set B. All of the other elements in set A has an image in set B, but the element 6 in set A has no image in set B. So, this relation is not a function. Okay. Now, consider a relation from set A to set B as shown here. See, this is also not a function. Can you say why it is not a function? Because here see, here the domains means the set of all first elements in the relation, that is 1, 2 and 3, these are the elements in the domain. See, here the elements in the first set, that is the domains, are connected to more than one images. Here you see, the element in set A has an image 4 as well as an image 5 in set B. That is, the element in set A has more than one images. That is not possible for a relation to be a function. So, one has two images in B. So, this relation, it is not a function. Okay, so you see, function is a relation, but that is a special type of relation. A relation from A to B is said to be a function if every element of set A has one and only one image in set B. every element A should have images and it should have one and only one image in set B. So here 1 has 2 images in set B. So this relation. So a relation f from set A to set B is said to be a function if every element of set A has one and only one image in set B. In other words, we can say that a function f is a relation from a non-empty set A to another non-empty set B such that the domain of f, domain means the set of the elements in the first set. Okay, so domain of f is A and no two distinct ordered pairs in f have the same first element. That is, for example, let us consider this example 9 which we have already discussed in our previous videos. So here consider this as set A, this as set B. This is an arrow diagram representation for a relation. Okay, so here you see, is this relation a function? See, here in this relation, if we write the ordered pairs, we can write, you see the first element 1, second element 3. So 1, 3. First element 1, second element 4. So 1, 4. Then first element 2, second element 3. So 2, 3. First element 2, second element 4. So 2, 4. These are the ordered pairs here. So here you see, the first two ordered pairs have the same first element of 1. Similarly, the second ordered pairs, that is the third one and fourth one, they have the same first element. Okay, that is not possible for a relation to be a function. So this relation is not a function. Okay, because a function f is a relation from one non-empty set to another non-empty set such that the domain of that function, that is A, and no two distinct ordered pairs in f have the same first element. Here you see in this relation, the ordered pairs have the same first element. So this relation cannot be a function. And you see, if f is a function from A to B and A comma B belongs to f, then f of A equals B, where this B will be called as image of A under f and A will be called as pre-image of B under f. That is, if we consider a function in such a way that f of A equals B, then this B is called as image of A and A is called as pre-image of B. Now let us consider another definition. A function which has either R means set of real numbers, or one of its subsets, that is subsets of real numbers, as its range is called a real valued function. And if its domain is also a real number set or a subset of R, then that function is called as a real function. See, real number means natural numbers, rational numbers, irrational numbers, everything will come under real numbers. That is, suppose we consider a function from set A to set B. You see the set A, the set of first elements, that is actually called as domain, and their images will be in the second set, that is actually the range. See, if this range is a set of real numbers or subsets of real numbers, then that function is said to be a real valued function. If the domain is also a set of real numbers or subset of real numbers, that is both the domain and range are real numbers or subset of real numbers, then that function is said to be a real function. Okay. So in this video, we have discussed about the functions and two definitions. I hope it is clear to you. You will get a better understanding about these concepts when you solve the examples 11 and 12, which will be available in the playlist or in the description box, because those two examples are actually related with these concepts. So I hope all these are clear to you. Thank you.